Good morning and welcome, everybody. You are here for our first event of the school year, our bridge event, and you are in for a treat. We have the amazing Edgar Martinez who is going to be leading the day. But before we get there, just a few reminders. Please make sure that you are, if you have the capability, turn on your cameras. I see some amazing classrooms and some students ready to roll, which is amazing. But let's get rolling. Edgar, I think it's time. They're ready. We have 30 minutes to get into this bridge lab because I'm sure that they are eager to get their hands on those kits.
I'm excited about it. So good morning, everybody. On behalf of Engineering Tomorrow, I'd like to welcome you to today's presentation on bridges, right? I'm in New York City, so greetings from New York City. My name, again, is Edgar Martinez, and I'm excited to share some of my experiences and passion in engineering, right? Today, you have a bridge challenge, so we're going to talk a little bit about what that means. After we talk a little bit about bridges, right? Before we get started, of course, I'd like to share some guidelines that I hope everyone will follow just to make this experience as positive for everybody as it can be. Please, please, please participate. Ask questions. You see a picture, you see something, you see a figure. Do not be afraid to ask questions, right? See something and you're curious about it, ask. Don't be shy, right? And if you don't have the opportunity to do that because in your school you're not at a computer, write the question down and we'll answer it later, okay? I do invite everyone to please, please be respectful of each other and of course of yourselves. And then finally, let's have some fun, okay? So before we get started, I'd like to start with some thank yous, right? This is the breakout development team that developed this challenge for you. Joanna Caudell is in actually one of the rooms in school somewhere today, and she's also working with this challenge. And then we have some interns. Hello. We do have some college interns that also work on this lab, okay? So a little bit about me before we get started. I am a graduate from the engineering school at Columbia University here in New York City. I do have a BS in civil engineering. Um, my concentration was in construction management because I was interested in working on delivering heavy infrastructure. For those that don't know what infrastructure means, right? Infrastructure is just all the basic structures and systems that a society needs. So we talk about roads and bridges, which is what we're talking about today. Buildings, utilities like water supply, electricity, gas, transportation systems, right?
Good
So
morning.
good morning. How's it going? So let's think of like infrastructure as the foundation that supports our daily lives, right? So here in New York City, I work for a heavy civil infrastructure delivery outfit called John P. Picone, where I work on water treatment plants. I also had a chance to work for the underpinning division of Skanska. We actually were building the foundation for tunnels that ran underneath New York City, right? And then I also had the opportunity to intern with Parsons Brickhoff when they were working on the Third Avenue Bridge. So I have some really cool pictures about Third Avenue Bridge. The Third Avenue Bridge is a bridge that connects the Bronx, which is one of the boroughs in New York, with Manhattan, which is another borough in New York. And you can see here some really cool pictures. There was a demolition phase. We had a really old bridge. So I know that one of the questions that I saw from students that asked across the country was, how often do we look at bridges? How often do we inspect them? Usually 2 years, right? That's usually what it is, depending on where you are. Also, the conditions that surround the bridge. So, for example, if you're working in a situation or the bridge is over a place that's like, I want to say heavy salt water, right? That kind of stuff. You have to do it a little bit more frequency because they are subject to rust. But what I want to talk to you about here is these pictures look really cool because this bridge had to be demolished, right? Taken apart, and that there had to be a plan for that, right? Additionally, this bridge was built in Alabama, so it had to be put on a special boat, a special barge, and then traveled to New York City, right? Took about 2 weeks to get here to New York City, and then we had to put it in place. So it was really cool to be able to see the bridge coming into New York Harbor, right? So here's some more pictures. And then I think there was another question, right? I think there was another question that I read about. Someone said, well, in my local town, my bridge came down, right? And so that created some issues. What's the issue with that? Well, yeah, usually here in New York, when a bridge goes down, there is a whole process on working on the transportation around it before they demolish the bridge. But sometimes you can't do that because of catastrophes, right? Um, in rural locations, isolated locations, that's even harder, right? In New York, there's other routes that you can take, but some places that are really isolated, you don't really have that option, right? So um, that's probably a problem that you're going to solve at some point. So again, if you have any questions later on, please feel free to ask me about this really cool project that I got to work on here in New York City. So let's start talking a little bit about bridges. Definition of bridges. By definition, a bridge is a structure that spans physical obstacles, right? A river, a canyon, right? And you have to make sure that that bridge is safe, right? So that people can go over it, right? So anything that we put
I
on
think
that, anything that we put on that bridge is called a load, right? A load, and that's going to add some weight to that bridge, right? We call those live loads, right? Additionally, you also have the weight of the bridge itself, and that's called its dead load, right? So those are things that you have to balance. Here you have three different types of bridges. So you have one that it looks like an arc type bridge, right? You have one that a U-beam bridge where it looks like it's made out of wood, right? And then you have a really nice bridge on the right side that is a cable stay bridge. I'm going to give you about 30 seconds to try to think about how many bridges you think there are in the United States, right? Think of a number, right? Usually these questions are called Fermi questions, or you try to figure out how many of something there is somewhere, right? So maybe think about how many bridges you used this morning. Think about how many bridges you see in your city, and try to expand that out. I'll give you about 10 more seconds or so. See if you got pretty close. So the answer to how many bridges, there are over 617,000 bridges in all of the United States, right? Which is pretty cool to think about, right? If you are thinking about working on bridges or working as a civil engineer, right? There's always going to be a job because, like I said, all of these bridges have to be inspected from time to time, and they're going to have to be replaced, right? So moving on from that, right? We talk about our passion for engineering, right? And a bridge is much more than just a structure, right? Communities have been building bridges to make connections that increase opportunity, right? When you have people that live in rural locations, right? Them not being connected to markets and schools and doctors is part of poverty, right? So later on today, our keynote speaker, Avery Bang, is going to talk to us a little bit about how important it is that these bridges reach all these isolated communities, right? People really need to be able to get to markets around the world. People really need to get to doctors around the world, that kind of stuff, right? So if you didn't know, in a study of communities with and without bridges, those with access to bridges earn 30% higher incomes. So having a bridge is really, really important just to have a better life. Again, in your life, just think about this morning when you woke up, right? How many bridges did you cross to get to school, right? Sometimes you think about it, sometimes you don't, right? So bridges have, of course, undergone a really long changes in material, right? Over time, iteration, changing it. So we start with simple bridges that are just basically trees. And over time, we've gone into stone bridges, right? And now a lot of us use steel bridges, right? So again, over time, the material has changed, right? Iterations, making improvement on old designs, how to make them lighter, how to make them stronger, what kind of materials do we use, okay? So, and even though bridges, though they look the same, okay, they all have different purposes. So here we have four types of bridges, which you can see on the top left side, you have something called a support integrated transportation system. That's just a fancy word for a bridge that uses more than one kind of passenger, right? So in this case, you might have trains, cars, you might have trains, cars, and people, right? You may have bicyclists and people and cars, right? So that's kind of what that means. Sometimes you have to build a bridge over a long span of water, and that may mean that you might need different type of material or different construction technology, right? So that 7,700-foot floating bridge required some pontoons to build, right? You might also need to get access to places that have undergone a natural disaster, like an earthquake or fires, that kind of stuff, right? So sometimes you have these mobile bridges, origami bridges that almost extend out so you can reach certain places that are not accessible to get people out, right? And of course, then you have bridges like this cable stayed bridge on the bottom right, and those just, the architecture on them is really nice. Changing the architecture on a bridge changes what a city can look like, right? So sometimes these bridges are marquee to certain cities, right? Which is really nice. In order to build bridges, of course, they all have the same design fundamentals. You have to balance their forces. So I think earlier we spoke a little bit about live load and dead loads, and we'll talk about that again right now. So a live load is all of the kind of pressures that a bridge is going to face, right? A bridge is just like you, right? Think about going to school, all the pressures that you feel, right? How do we address them, right? And the pressures have to be balanced. So what are the pressures that we talk about? We talk about compression, things that are getting squeezed, and tension, things that are being pulled apart. And then, of course, you have to talk a little bit about stress and strain. Stress is just basically pressure over area, right? And strain is how much something deflects. Believe it or not, believe it or not, all bridges have to bend, right? If they don't bend, if there is no strain, that is a little bit of a problem. Think of a glass bridge, right? If you had a glass bridge and that cracked a little, the whole bridge would collapse, right? So you don't want that. So you want to use materials that do give a little bend, right? That's going to be really important. Um, Moving on, right? You're going to have many design options. So when you start to work on your challenge, you might want to do a little bit of research. When I was going to school, one of my construction management professors used to say, proper prior planning prevents poor performance. A lot of alliteration, right? Proper prior planning prevents poor performance. So as you start looking into what your design option is going to be, think about the materials that you have available for you. Think about the function. How strong do you want your bridge to be? Also think about cost, right? Part of today's breakout challenge is for you to make a bridge that is not only strong, but it is cost effective. Okay? So think about those things. So as you're doing your research, do you want to build a truss bridge? Does it make more sense to build a beam bridge with what I have? Maybe use trusses, right? Trusses use a lot of triangles because triangles are really strong in compression and in tension, right? Do I want to use a cable stayed bridge? Is it necessary, right? Do I want to use a cantilever bridge, right? Things like that. So do your research, right? To do some research. Your bridge challenge today is going to break up into two portions, right? A design, you're going to design it first and then you're going to build it, right? So before we move on to that, let's do a little bit of recap. Remember that bridges design depend on function, location, material, and budget. In your case, what do I have and how cheap do I want it to be and how strong do I want it to be, right? How cost effective and how strong I want it to be. Think about balancing tensile and compressive forces, right? And then just know that bridges are built using the engineering design process. So what is that design process? That design process is basically a little bit about doing some learning, doing some research, doing some preliminary designs, building a prototype, right? You're going to build the bridge today, right? And then you're going to test it. How are you going to test it today? You're going to load it with some weight, and then you're going to break it. I know that you're going to spend a lot of time building these bridges, and you might not want to break them. That's the fun part. All right. So take some time to do that. And as the bridge breaks, to try to take some notes, right? Where did it break? Why did it break? Was something did I not use the right shape? Was something not glued correctly? Things like that. Okay. So these are just some equations that are used when you do a little bit of bridge design. And what I want to bring to your attention is just this last equation, right? Those of you that are not good at math or are hesitant for math, don't even worry about it. You don't need a lot of math for this. But just know that this x value here is basically how much a bridge will move. And that means that it's a function of force and of length, right? Force, length. It's also a function of the material that you're going to use and the shape. So things that we spoke about, right? The nice thing about engineering is that you already know it, right? Intuitively, you already know it. Now you have to apply it, okay? So moving on, these are just different types of practices that you may use in your classroom before you start challenging yourself to make the real bridge, okay? But just know that these are the materials that you have available today. So you're going to have 75 dowels. You're going to have 50 popsicles, okay? You're going to have this mending plate on the top left-hand side and those hooks. The aluminum stuff you're going to use for testing, so that you're going to put to the end. But the dowels, the popsicle sticks are what you're going to use to build your bridge. You also have masking tape, duct tape, and hot glue, which is optional if you wish. Okay? So what are we doing today? We are building a bridge. Start by doing some research. Do I want a truss bridge, cantilever? Right? Think about what you want to do. Design your solution. As I said, it's easier to make changes on paper. It's really, really challenging to make changes once you're built, once your bridge is built, okay? And then, of course, you're going to build your first prototype, then you're going to test it, and then you're going to analyze results. I always say, as the bridge is breaking, maybe, I don't know what the policy in your school is for phones, but maybe you want to record it and then go back in slow-mo and see how it's breaking, right? Because then you can start to think about ways to tinker it later on. If you had to build it again, what would you do different, okay? So there are, of course, some constraints, right? Constraints is what makes this challenge really, really fun. So your bridge must be 12 inches or longer in length. It must be 3 inches or less in width. That's going to be where you run your traffic. right? The bridge can be as tall as you need it, and you can use any materials that you find on top of the stuff that we sent, okay? To test it, of course, you'll need 2 chairs, right? About 11 inches apart, all right? You're gonna place your bridge on top of that, and then you're gonna load it, right? The reason that you want the little overhang at the end of the bridge is so that it sits on something, right? And then you're gonna use the testing kit that we sent, right? So let's watch a video of someone testing it. I'm gonna stop right there just to bring your attention to a couple of things. So just notice that there is an overhang so that the bridge can sit on something, can rest on something. And you can see here that the bag is pulling down. You probably want to load your bridge right at the center because that's where most of the load is gonna be concentrated on, right? And you can actually see that's starting to deflect here a little bit, right? So again, if you have any questions about that, we can talk about that a little later. So let's move on to the next slide here. So of course, to analyze your results, you're gonna give all the material you use a cost. And remember, you want to have a really, really strong bridge, but you also want to win the competition if you're making a competition by having the lowest cost possible. And that actually happens in real life, right? When you're building a bridge, they usually give the contract to the person that's going to build it the cheapest, right? So think about that. These are the prices. Of course, you have this in your workbook, right? So think about as you are designing your bridge on paper, right? Proper prior planning. Think about what do I want to use? Do I want to use a large dowel stick, right? Is that going to cost me too much or too little? And analyze your results, okay? And then finally, if you have any questions or you want to know more about today's breakout, please look into bridge design or tunnel design, right? All the infrastructure that we spoke about. Okay, we're about 27 minutes in. I know you're excited and getting ready to build your bridges. I can't wait to see what you guys built. So with those 3 minutes left, I'll take any questions that you have, and then I'll let you guys go to build the bridge. Anybody?
I saw some schools were trying to unmute. So please, if you have a question, Edgar is ready for your questions if you want to unmute.
Anybody?
If not, you can put your questions in the chat.
Yep, I'm going to chat right now.
There was a lot of hellos in the chat and good
All right.
mornings. And some people were having some audio issues. I hope that they were fixed. But
All right. If not, that is 28 minutes on the dot. So may your bridges be strong and may they be cost effective. I wish you good luck, and I can't wait to see what you guys built later on. Thank you, everybody.
Well, we are going to open up the breakout rooms since Edgar has gotten that intro ready, and I know you guys are eager to get those kits and rolling. Breakout rooms are open. If you need assistance to get into the breakout room, just let us know. We will be back in the main room at 11:30 for our wrap up, where we want to see what you guys created. So be ready at 11:30 to share, teachers and students. And I'm going to